See, in this question, it is given fxy equals to 6 into 1 minus x minus y for x greater than 0, y greater than 0 and x plus y is less than 1 and 0 elsewhere. So what we need to find? We need to find the marginal distribution of x and y. So if we need to find the marginal distribution of x, it is fx of x, which is nothing but integration up lower limit of y and then upper limit of y, f of x comma y dy, right? This is the formula. Now we need to calculate the upper limit of x, right? We need to calculate the upper limit of y, so observe this line, x plus y less than 1. So what is the if I write the line x plus y equal to 1, okay, if this is the line x plus y equal to 1, then this point is nothing but 1 comma 0, and this point is 0 comma 1, at this point is 0 comma 0, the origin. Okay, now obviously from here I need to get the upper limit of y. So the upper limit of y is not 1. Okay, it is not 1. I have to use this to find the upper limit, or let's say I will just leave this x plus y less than 1. It will be more confusing. Leave it. X plus y equal to 1. So from here I can get the upper limit of y as y equal to 1 minus x, right? Y equal to 1 minus x. I will be substituting this over here. Now I can easily see that it is basically from 0 to 1 minus x, f of xy dy. So what is f of xy? It is 6 into 1 minus x minus y dy. Now if I do this, what I will be getting? 0, 1 minus x, 6 minus 6x minus 6y dy. Okay, so it will be integration 6 dy minus integration 6x dy minus integration 6y dy, and the limit is from 0 to 1 minus x. So finally I am getting 6y minus 6xy minus 6y square by 2, and the limit is from 0 to 1 minus x. So I will be putting 1 minus x over y, right? Over y. So 6 into 1 minus x, that is, yes, like this, minus 6x into 1 minus x again, minus 3 into 1 minus x whole square this time. And I know if I put 0, I will get everything as 0, so no need of putting. So it will be 6 minus 6x minus 6x plus 6x square minus 3 into 1 minus 2x plus x square. So it will be 6 minus 6x minus 6x plus 6x square minus 3 plus 6x plus, no, minus 3x square. So minus 6x plus 6x will get cancelled. It will be finally be 6x square minus 3x square. It will be only 3x square. Then minus 6x and 6 minus 3 is plus 3. So it will be 3 if I take common x square minus 2x plus 1. So it will be 3 into x minus 1 whole square. So this is fx of x. Okay. So marginal density of x is 3 into 1 minus x whole square. Now what I need to find? I also need to find the marginal density of y. So in order to find the marginal density of y, we have to use the formula f of y. Y is nothing but integration 0, lower limit of y, lower limit of x, okay, x lower, x upper, f of xy dx. Now what is the lower limit of x? I can see from the figure that x is greater than 0, that means the lower limit of x is 0. What is the upper limit? I also know that x plus y is less than 1. So from here I can get as x plus y less than 1. Let's say x plus y is equal to 1. So x equals to 1 minus y. This is the upper limit. Put it over here. And then 6 into 1 minus x minus y dx. So it will be integration 0 to 1 minus y, 6 minus 6x minus 6y dx. Now it will be 0 to 1 minus y. Okay, integration 6 dx minus integration 6x dx minus integration 6y dx. So it will be 6x minus 6x square by 2 minus 6yx from 0 to 1 minus y. So it will be 3. Okay, so now it is basically 6x minus 3x square minus 6xy from 0 to 1 minus y. I need to put 1 minus y over x, so it will be 6 into 1 minus y. Okay, wait 6 into 1 minus y minus 3 into 1 minus y whole square minus 6 into 1 minus y into y. So it will be 6 into 1 minus y is nothing but 6 minus 6y minus 3 into 1 minus y whole square, that is minus 3 into 1 minus 2y plus y square. Okay, minus 6y into 1 minus y, that is minus 6y and plus 6y square. Plus 6y square. So finally 6 minus 6y minus 3 plus 6y minus 3y square minus 6y plus 6y square. Finally this will be 3y square, then minus 6y plus 6y cancelled, so minus 6y and then plus 3. So I take 3 common, y square minus 2y plus 1. So it is nothing but 3 into y minus 1 whole square. So this is basically the fy of y, 3 into y minus 1 whole square. Done.